Hello students, welcome to another video of calculus. Today we will discuss some another definitions and the definition of limit. So the next definition is definition of rational functions. So the next definition is definition of rational functions. Rational function. A function of the form p of x upon q of x is said to be rational function. A function of the form f of x is equals to p of x upon q of x, p of x upon q of x, where this p of x and q of x, where this p of x and q of x are polynomial functions, is called, where p of x and q of x are polynomial functions. These p of x and q of x are polynomial functions. So function f of x is equals to p of x upon q of x, that is the rational function of two polynomials, here p of x divided by q of x. Then this function is called, this function, that is p of x upon q of x, is called rational function, where p of x and q of x are polynomial functions, is called rational function. It's called rational function. Now the next definition, if we take one example of this, so suppose f of x is equals to 1 by x. Here 1 is also polynomial, because we can write f of x is equals to 1 plus a naught into a1 into a1 is equals to 0 into x. So here 1 is polynomial function, again x is polynomial function, so their division, that is 1 upon x, is a rational function. Similarly, if we take another example, suppose g of x is equals to x upon x square plus 1 is also a polynomial function. These are the examples of polynomial function. Now the next definition is exponential function. Next definition is exponential function. Next definition is exponential function. So the function of the form b raised to some x is called exponential function. Let b be a positive real number, b be a positive real number such that b is not equals to 1. So positive real number greater than 1, then the function of the form f of x is equals to b raised to x, f of x is equals to b raised to x, it's called exponential function. It's called exponential function. Generally we take b is equal, instead of b we take e, so e raised to x is called exponential function, but this is not a for particular e. For any positive real number which is greater than 1, we can take b raised to x as exponential function. For example, if we take, suppose b is equals to 3, then f of x is equals to 3 raised to x is also an exponential function. Now the next definition is logarithmic functions. The definition of logarithmic function. logarithmic function. The function f of x is equals to log x. F of x is equals to log x, where base of the log is suppose a, where this a is non equals to 1 and greater than 0. Again positive real number greater than 0 but not equals to 1 is called logarithmic function. It's called logarithmic function. Logarithmic function. It's called logarithmic function. Now the next definition is trigonometric function. Next definition is here the definition of logarithmic function, exponential. Now trigonometric function. Definition of trigonometric function. The functions which is equals to sin x, cos x, tan x are trigonometric functions. The functions y is equal suppose sin x, cos x, y is equal suppose tan x. These are the trigonometric functions, etc. are called trigonometric functions. Are called trigonometric functions. Now the next definition is absolute value function. That is, we have seen absolute value in chapter first, that is modulus of real number. Now the next definition is absolute value function. Absolute value function, that is function defined as f of x is equals to mod x. The absolute value function from R to R, from real numbers to real numbers, is given by mod x, that is absolute value of x is equals to x and minus x whenever x is greater than or equals to 0, and minus x whenever x is less than 0. So this is the definition of absolute value function. Or absolute value function can be given as f of x is equals to mod x, and we know that mod x is equals to x whenever x greater than or equals to 0, and minus x whenever x is less than 0. Now the next definition is increasing and decreasing functions. Increasing and decreasing functions. Increasing and decreasing functions. So let f be a function, f be a function defined on closed interval ab, and let x1 and x2 be the elements of that closed interval ab. Then that function f is said to be increasing. First, f is said to be increasing on given interval. Suppose that interval ab is equals to I. On I, if f of x1 is greater than f of x2, f of x1 is greater than f of x2 whenever x1 greater than x2. Function is said to be increasing when f of x1 greater than f of x2, whenever x1 greater than x2. And second, f is said to be decreasing. F is said to be decreasing whenever decreasing on I if f of x2 is greater than f of x1, that is f of x1 is less than f of x2 whenever x1 is less than x2, whenever x1 is greater than x2. F is said to be increasing if x1 is greater than x2, then f of x1 is greater than f of x2, then function f is said to be increasing, and f is said to be decreasing if f of x1 is less than f of x2 whenever x1 is greater than x2. Suppose x1 and x2 are two numbers from the given domain closed interval AB, then we say that function f is increasing if x1 is greater than x2, then f of x1 greater than f of x2. That is, in another words, we can write it as, suppose x1 is less than x2, x1 is less than x2, then f of x1 less than f of x2, then the function is said to be increasing. For suppose if for 1 and 2 are the elements of this closed interval AB, then suppose f of 1 is equals to 1 and f of 2 is equals to 2, then we can say that x1 is less than x2, so f of x1 is again f of x2, so function is increasing. Similarly, conversely, the decreasing for the decreasing function, if x1 and x1 is less than x2, then f of x1 is greater than f of x2, then function is said to be decreasing function. This is the definition of increasing and decreasing function. Now the next definition is the even and odd functions. Even and odd functions. Even and odd functions. So let a function y is equals to f of x is called even, if f of x and f of minus x both are equal. F of x and f of minus x are both equal, and odd function, that function y is equal to f of x is called odd function if f of minus x is equals to f minus of f of x. F of minus x is equals to f minus of f of x for every x belongs to the given domain D. For every x in domain of given function, domain of the function, that is f of x is equals to f of minus x is equals to f of x, then function is even, and f of minus x is equals to minus of f of x, then given function is odd function. For example, if we take, suppose f of x is equals to x square, then clearly f of minus x is equals to minus of x square, and minus of x square is again positive x square, because we know that square of negative number is positive number. So f of minus x is equals to this f of x. So this function is even function. And now if you take, suppose f of x is equals to sin x, then f of minus x will be sin of minus x, and we know that sin of minus x is equals to minus of sin x, so this will be the minus of f of x. F of x is sin x, so minus of sin x is minus f of x. So this function is odd function. This is the definition of odd and even function. Function f is said to be even whenever f of minus x is equals to f of x, and function is said to be odd if f of minus x is equals to minus of f of x. These are the some remaining definitions. Now in the next lecture we will see the definition of limit.